We don't. I don't know what happened, why the audio keeps not working. So now we have audio again. Congratulations. Alrighty.
Okay, ready?
I think I'm as ready as I ever will be. So.
Okay. So here I'm like showing two scenarios of using DataFrame. One is notebook / Studio. The other one is Spark.net. This one is like Visual Studio. So here what we're doing is we have issue / PR data from GitHub for the core effects repo. That's in the GitHub issue downloader format.tsv. Okay. So the data, it has a bunch of columns. The important one for us is that it combines both PRs and issues into one set of data. So the first thing we're doing is filtering it by that column. So line 98, it says df is pr.elementwise equals 1. So ones are all PRs, zeros are all issues. So that's what the lines 98 and 99 does. Then the aim in this demo is to train issue labeler, so similar to what Miriam is doing. So for the issue labeler, we don't actually care about the ID column and the 5 paths column. So we remove that from our data set, which is line 104 and 105. The other thing we're doing is it has a description column. And usually what happens in issues is somebody writes up an issue and then mentions like one of us in the core effects team. So that is correlates well with what the label for the issue should be, which is what the bot is supposed to predict. So what I'm doing on lines 111 to 117 is going through the description column, and I have a regex to figure out the user mentions. So if there's a ad like Eric Earhart, so that would come out as data from the description column. So that is going into a new column called user mentions. And then I'm adding the user mentions column to the issues data set, to the issues data frame itself. So then if you scroll a little bit bottom.
Sorry, just apply element-wise is mutating. What is it mutating?
So apply element-wise, in this case, is not mutating any. In this case, the apply element-wise is on the description column. But what it's really doing is setting data in the user mentions column.
But it's returning something. Yeah. What is the purpose of the return, correct?
So in this case, I just needed like a convenient enumeration, so I just used that API. It's not. I could change. In this case, it's just returning the same thing that it finds. So like current would be whatever data it has at the moment, and then it returns the same data back.
If I had returned null, would it actually overwrite the elements of the description column?
Yes.
Okay.
It's
so it is mutating. It's just mutating it with itself.
Yes.
Do we need maybe like a for each instead of? Actually, I think Steve, you said that list of t.for each you thought was an API misdesign, right?
I mean the string column is an IEnumerable of strings, so the for each should just work. It could be
right.
for each string in description, and that will also do the same thing.
Yeah, you need the row index to come in.
Right.
Yeah. Interesting.
Actually, that's the reason I used the apply element-wise, because I needed the row index.
I don't have the answer. It just feels weird. This is showing sort of the ultimate use of the API. It feels weird that we're using it in a way that's non-obvious in order to achieve what we want.
Yeah, I would expect something like for I equals 0, I function length or something.
Well, yeah, I could do that also. Yeah.
So some things that we do on other collection types, like dictionary, for instance, is we have some helper properties hanging off of them. So, for example, string data frame column could have a property like pairs off of it, where pairs is IEnumerable of tuple string long, for instance. That way, you could say for each var pair in description, and then pair.current, pair.row index, or whatever.
Okay.
That way, you use syntax. It's a little bit more C#. Like ignore the names that I just mentioned, but the syntax looks a little nicer, right?
The apply element wise just gives you
list though.
Sorry?
Wouldn't you want that on any list?
Well,
to be able to enumerate over the things and have the index at the same time?
Well, you already have that. It's called select.
Well, select is actually returning a new IEnumerable, though. whereas a for each is just operating based on the contents of it. Like you're right, presumably you would want that on any list of T, but on any random list, generally you can just say for int I equals 0, blah, 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 blah. Whereas it sounds like here the row index might actually be interesting for the scenario.
I guess just doesn't understand like why the ideal isn't just a for.
Yeah.
I mean, kind of seeing a scenario where this could run in parallel or like on multiple PCs, I guess, but I don't think this is a this is working at the moment.
So just use a regular for loop is the
Right.
is the idea.
I could have also used regular for loop. There's nothing that's preventing me from using regular for loop.
Is the performance of using a regular for loop acceptable?
Not always, because of the backing store. So it holds a memory of bytes, and then when you have, say, like a column of integers, you go from a memory of bytes to a span of int. And so each time you do a for loop for every index, you keep converting from byte to int, byte to int. So
You keep calling
for the span.
keep calling the span property together.
Yeah.
Okay. And apply element wise doesn't do that.
It caches the it goes to the bytes, caches the whole span, and then you go through the span. You do a for loop, you always hit the byte and then go to the span on each.
But it's also invoking a delegate for each operation.
True. Yes.
So you're comparing the cost of a delegate invocation
And
against
still using the
.span.
indexer.
In this case, so like if you on the column that you're doing the apply element wise, if you only modified that column, then you won't be using. So here you're working on different columns indexer, right? So there you hit the memory and then span. You do the memory marshal thing. If you're working on the same column, then you don't do that. But Steve Tobe is right that yes, we're comparing delegation versus.
Is it possible that
Also, I also have no idea if this is a typical use, but those costs are going to pale in comparison to the regex.matches.select.to array and the string.join that immediately follows.
Sure, I know. This is more. Like this is not the most efficient code like anybody could ever write. This is more to like throw the user scenarios to see like where DataFrame is used.
It's useful sample code though.
That's kind of my point. Is like there are APIs where one designs them for the absolute minimal overhead possible, and there are APIs where one designs them for usability. And thus far, this seems like one that's intended to be designed for usability.
Yeah.
Because the core work that's done is either very expensive and done in user code, and so the cost of accessing the API doesn't matter, or it's performed by the API itself, and the API itself optimizes the implementation. Now, maybe there's something in between, and I'm waving my hands a lot, but at least based on this sample, it feels like overhead of calling memory.span is irrelevant.
It's not just memory.span though. Just an FYI, is that the data is actually stored in a memory of byte chunk. And when it's a column of ints, that byte needs to get reinterpreted to ints. Right? Like,
So are you saying that indexing into the column is order n?
No, it's not. It's order one.
It's getting the span out.
Yeah.
It's not just as simple. What I'm saying is it's more expensive than just getting a span from a memory, because the backing memory is a memory of bytes, right? And then when you want to get the span, like when the column is a column of ints, right? The backing data is still memory of bytes, and so in order to get a span of ints out of it, you have to do a reinterpret cast kind of thing.
Oh, but that's cheap.
It's still cheap, yes, but you don't want to do it. Like if you were trying to write performant indexing code, right, you wouldn't want to do it on every element.
I'm not even convinced of that.
Well, reinterpret cast is intended to be free.
Yeah, I was about to say,
It's
I thought the
free.
cost was very close to zero, if not zero.
I mean, my profile link.
Potentially we're doing it wrong, but
Interesting. We should actually take a look at that offline,
Yeah.
Okay.
because that's something we should address.
And I have a question. So is row index generally going from 0 and like consecutively one by one
Yes.
up front, or is there like a way that you filter out some kind of data frame beforehand and then you kind of skip a couple of elements?
Okay, in this example, it goes from 0 to whatever the length of the column is, but it could, in theory, be it could in theory be different row indexes. You have, yeah. So there's some APIs where you can go on a column and then you can get not random indices, but indices you desire. So there's a filter call that will give you indices for whatever thing you gave. That will be a column of indices into your original column. There, if you do element-wise, the row index be.
So in that case, the regular for loop wouldn't work. You would have to use kind of for each. And that might potentially be more expensive.
I don't know if you have to use this API. Like wherever apply element-wise is, you can always use a for loop. There's no particular reason to use this other than if you don't want to pay for the going from memory of bytes to span.
So I mean, I get apply element-wise when you're rewriting everything in the column. Like that makes total sense to me. It's a convenience thing.
Yeah.
Like the sort of fluent syntax if the description were being pulled from somewhere else. Like I get it. The thing that sort of raises my spidey sense is then using an API for something that it's not really intended for.
Sure.
And in this case, it's being sort of used in an unorthodox fashion to rewrite itself to itself, and take as a side effect of that invocation being storing it into something else.
What if we had a convert method or similar? Because it sounds like in this scenario, you have an existing data frame column. You're trying to generate a brand new data frame column by applying some transform to each of the elements. So a helper function to encapsulate creating the new data frame and doing the conversion might be useful.
Just literally call it create new column and then pass a.
I don't know.
Okay.
I mean, yeah. I mean, I would have imagined that when I first saw this, my initial intuition was this is select. And it was returning a new column. And then I realized, no, it wasn't storing it into anything else. So then I thought, oh, it's mutating itself. Okay, but it's returning current, so it's mutating itself. So that's where I started getting confused. The ability to basically have a select operation or a map or whatever you want to call it that returns a new column seems fine if that's something people do.
Okay.
And in this case, it seems like maybe that is what's being done because just above it, there's the user mention columns equals new.
Okay.
So, yeah.
Cool. Yeah, I think about API that does that. That makes sense.
Is select the right word there for that? If
Or
we were
map,
to add this?
whatever. I mean, I'm surprised there isn't something similar in pandas, but if there isn't something similar, but whatever sort of the vernacular is, my guess is it would be map like that.
Yeah.
But if there isn't, then I would use the thing that's familiar to .NET devs, but my guess is it's map or something like that.
Right. We don't really have map anywhere else, do we?
No.
In .NET land, no.
So potentially select would be the operator here. That would take in a value, turn any value really, right? Because you could select strings and turn around and count things and return an int, right?
Right.
So in this case, we're making it a select that is not mutable.
It's a creation routine. I don't know how you would fit the API in because, like, how do you know what the return type should be?
Right.
Well, presumably it would be just like select, generic inference.
But it would have to be a primitive data column of T kind of thing.
I mean,
like
we'd have to take
which data column do you want to return?
We'd have to take at least one.
Turning ints.
Because you're explicitly creating a string data frame column. I see.
Yeah.
Right.
Because there's a different type system.
Yeah.
Well, it's because there's strings, right? Which what each element is, and then the thing you're actually wanting to return is the column.
Right. No, but presumably anytime you create a string data frame column, it only contains strings, and presumably any column that contains strings generally is a string data frame column.
In most cases, not always though.
We actually have two different kinds of string
Right.
columns. One that's backed by actual .NET strings, which are UTF-16, and then another one that's backed by the arrow format, which are UTF-8 bytes, and all the values of those are stored in one contiguous buffer, and then Like basically the blanks and the pointers between each one of them are stored in a different bucket.
Well, to avoid further bogging down the review, it sounds like something that should be discussed offline further.
Select sounds like a find operator.
Okay. And so we're almost at the end of this example. So here what I'm doing is I have this set lines 120, lines 117, I'm adding the user mentions column to the issues data frame. So whatever ML model you want to run on it actually has more data on it. Line 120, 121, I'm splitting the issues data frame into 3 data sets. There's one training data set, one validate data set, and then one test data set. Then after that, we don't care about what the auto ML stuff does. So this example is just to show how you can prep the data using data frame. Right. So this is like
train test is your own helper.
Yes.
Can we go to those?
Imo, can you? I'm not certain that it's on this file. Okay. All it does is it has enumerate 0 to 80%, and then there's a filter on. It takes the first 80% of the rows, then it takes the next 10% of the rows, and the next 10% of the rows. I don't have split train test maybe in a different file. So if you scroll down.
So one thing about that is when you actually do this in machine learning, you don't want the first 80%. You want a random 80%.
Right.
And this is kind of, I think we talked about this in the last time, where that's where the indexer that takes in each column that you want, or each row that you want, like an IEnumerable of row indexes. That's where that one comes in.
Right.
Do you know what I'm talking about? Like if I have a data frame of say, 1,000 rows, and I want to get a new data frame picking out half of those rows, but they're going to be shuffled, right? So I want row 1, and then I want row 10, I want row 5, and then I want 15, and row 12.
Okay.
Does that make sense? Yeah.
Okay, so for the next one, Imo, could you scroll just a little bit to the top? Just before the fact. Oh yeah, they're right there. So this one is a Spark.NET like use case. So here, this is the initial data that we're looking at. So this one is Uber data, I believe, from 2015 for the month of Jan and Feb. So here what we have, the columns are city ID, which is kind of some ID for the city. We have a date, the number of active vehicles on that day, and the number of trips on that day. The task here is to find the number of trips each day of the week for Jan and Feb. So it's kind of a Spark like task. So the first thing that Spark does in its flow is it splits this and gives us data such that you have for each city you have all the columns for each city. So so for city 2512, this would give me data for first, second, third, fourth, blah blah, 31st, and then it give me the corresponding active vehicles and trips. So if you scroll further down, Imo, you can see that that data would look like that. So for 2512, you have those columns and those numbers, and Spark would give us the data. All of the 2512s would be given to us as one data frame. Then all the 2765s would be its own data frame, and so on. And then Imo, go further down to the end. Yeah, okay. So here what I'm doing first is converting the date into the day number of the week. So that's what lines 189 to 192 do. And I'm putting that into its own column called the day number column, and then adding that to the input data frame.
So you have, so get day number is returning an int?
Yes.
Okay.
So this would give us a 0 to 6, the day of the week.
Okay.
So then what I'm going to do in line 199 is group by the day number and then call sum on it. So what the group by does is this would group the row numbers. So you have You have everything for Monday, then you have everything for Tuesday, Wednesday, Thursday, blah blah.
Okay.
And then the sums up all the active vehicles and the whatever the last column was for all of the Mondays, all of the Tuesdays, blah blah. The only thing between those two that I did is there's a date column, and it didn't make sense to sum the date column, so I just removed it from the data frame.
Okay.
And then you just return the data frame. That's it. This is an example that shows where you can use like a group by.
So this data frame has 7 rows then?
Yes.
One for each day of the week?
For each city, yeah.
For each city.
Yep. And then this would be called in a loop. So Spark would call this for one city and then the next city and on and on. So this shows like one part of the pipeline.
Okay.
Cool. So now we can look at the APIs.
And you said sum is summing every column then in the
On the
in the
group
data frame.
on the group
On the
data
group.
frame.
Okay. Got it.
Yes.
Perfect.
Not just.
Yeah.
We look at data frame first. I
Yes.
guess this makes probably the most sense.
This is the old one.
Yeah, I updated it. It's the same with it has the comments, but it's the new API.
Oh, okay. Do we just want to go through the API or?
So let's just start from the beginning then. So
Oh, okay.
data frame, so it takes. So I think that if you call the parameterless constructor, you're expected to add columns by doing .columns
Yes.
.add blah 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 blah. Okay.
Yeah. So the next one wraps the data frame columns.
Yep.
Why not enumerable? Instead of IList?
They do have an order.
Sorry, say that
That's
again.
fine, but it's not actually storing the columns list, right? It's copying the columns out and storing it into its own data structures.
We're not cloning the columns.
You're not cloning the columns, but you're not storing.
Are you
like,
cloning the
data
list?
frame doesn't-
No, yeah,
frame
not
doesn't-
yeah, no. It only takes the pointers for the columns and adds it to the data frame.
Okay.
And you're just enumerating from 0 to n.
Yes, I think the reason I took an iList is I may have wanted a count property on the columns. Not strong enough. It could be enumerable.
Yeah, unless there's a really good reason. Otherwise, I'd
Yeah.
follow Christoph's suggestion.
Yeah, enumerable.
Is that ML iDataView it inherits from?
Yes,
And it didn't last time, correct?
it did.
It did?
Yeah.
I thought last meeting we had the discussion of how it wasn't compatible with the ML iDataView.
We had that discussion, and it ended with iDataView is the interface, like IEnumerable, and DataFrame is the implementation, and implementation like list of T.
Okay.
So I mean, think about iDataView like being the equivalent of IEnumerable in this world, and DataFrame being the equivalent of list.
Okay.
Yeah, Christoph's feedback was mostly around. It's not so much about the interface versus thing. It seems more like the concern was that the API surface and the way you interact with them does not feel similar.
Okay.
It just feels very different, even though they have a relationship.
Okay. I was for some reason thinking it hadn't inherited from iDataView previously.
There was another feedback point we had last time, which was the whole dependency on, what was it, Spark or whatever it was?
On Arrow. So
Oh,
yeah, we'll
Arrow,
see
yes.
that stuff. Yeah, we'll see that stuff as we go on.
Okay.
So columns and row columns gives it back the column collection. So that's one of the things from last time's feedback.
Yeah.
Row count just gives the length of the data frame. The next two indexers, the first one gives an element at that row, column. The next one, this long row index, gives you the entire row as an IO list of object.
Do we have no strong typed access?
Because the data frame, like the data frame class itself does not know, well, it knows its schema, but it's not exposed in any way. Like,
But the user, presumably the user who calls it knows this. Right?
yeah,
So
that's what I was going for.
But I mean, like internally, we don't store things as boxed objects, right?
No, but all of the weak APIs, there's no way to know what type you have.
Okay.
But is there any way the user knows, let's say I'm indexing into a column and I know everything in there is ints? Can they avoid the boxing cost somehow?
Yes, they can get to the strong typed column. And then once they have the strong typed column, there's strong APIs on it. Then they would avoid boxing.
I see.
Because a column itself you can cast to primitive data
Like,
type.
I see.
Column
I
has
see.
int.
Is
Okay.
there any reason why we don't have a generic overload for some of these, like a method for getting the column of a strong type? That way the user doesn't always have to explicitly do the casting themselves. They could just say like get column and return a column of type int. And then generic specialization could make that.
But how do I know that the column they're asking for is a column of int unless they tell me that it's a column of int, right?
Well,
Yeah, that's what the generic's for. They would say give me a column
Okay.
of, and then in the generic parameter they would say int.
Sure. Yeah, I could add API that does that.
But
At the
what-
moment, they would just get that column, and then the column has a data type on it, and then they would just cast it. But we could put that API.
Yeah.
What's the difference there between that and like the the indexer that's right above the Levi's comment, this column name, returning the base class and then the user casts it?
Because casting is annoying to write.
Yeah,
You're-
it would be mostly a convenience API for, I know this is type int, so you do the casting for me. That way I don't have to, every time I want to access a column, remember to cast it to the right type.
On this API that we're
But I have
talking
to
about
pass-
having a generic, is it the row index column index API that you want to make generic, or the give me back a column API that you want to make generic?
Give me back a column because the column will be the same type. The row would be mixed type, most
Okay.
likely.
I mean, if you have a very small number of data types, then it might be worthwhile to not even do the generic, just have to actually get primitive column, get string column or whatever, because then you have even less typing, right? If you make a generic, or whether I put the type name in angle brackets or whether I put the type name in round parentheses doesn't make a huge difference in terms of typing, right?
Because I would also expect most people are using one of the 10 primitive types or
Right.
string.
Right.
We do have, the plan is to make it open to anybody bringing their own types though as well.
Right,
Yeah,
but
you still need
just
the
an
base one.
FYI.
Right? You still need a get column one that just gives you data frame column, right? But like you would always have also the primitive one as a shortcut.
yeah, because the common case is probably going to be primitive columns rather than custom columns.
I can see people adding custom extension methods onto this type as well if they plan on populating it with custom columns.
Yeah.
So I have another indexer question. There are two indexers here, one that takes a long and one that takes a string. In
Yeah.
other collections that I'm familiar with, where there are named columns or something, both of those indexers would allow you to grab a column, right? The indexer is which column by number do you want, and the name is which column by name do you want. But here, the one that takes a long is actually giving you a horizontal slice, and the one that takes a string is giving you a vertical slice.
Hence my comment there, asking should we just say if you want to query by column name, use the columns property instead of an indexer here?
Or perhaps remove them and move them into columns there.
It also exists on the columns. So
Yeah.
you could get the columns and then get it by the column name.
Presumably, maybe we should do something similar to rows. Maybe expose some kind of structure, kind of proxy.
Yeah, because let me just raise up my comment a little bit, which is it feels weird to me that the indexers in general are giving back different kinds of things.
Yeah.
I mean, it's one thing if the indexer gives you basically like different types, so long it's the same operation, but horizontal versus vertical seems like a huge difference, right? Like,
Yeah, like if you want a vertical slice, then just use the columns property and use the indexer on that. Seems like the best way to do it.
Okay. So I could just delete the string column name indexer and just keep the long row index.
But I'm kind of wondering even about the other ones as well. Like all the other indexers are giving you back data frames, right? They're filtered. They're still giving you back vertical slices, filtering by which columns are included. And then there's this row index one that's giving you horizontal, right?
No.
No.
The everything between this long row column index and this string column name, those are completely different. They give you back full data frames.
I mean, these
That's
guys
what I
do.
just said.
But
Some of
they're
them are
filtered they're filtered by rows,
Right.
not by columns. It's the exact same number of columns, but
But they're
then
giving back rows.
your filter that you're passing into the indexer is picking which rows you want back in.
I see.
So if I have a like in the GitHub example, right, where each row is a new issue, and then there's columns, right? If I want to say, give me all the issues that are PRs, right, would have the PR filter tested.
This
So
feels like a
what is
select method.
what is the bool filter?
That's true false picks the row,
Yeah.
right? So if it's true, it's another series of booleans that's the same length as your data frame, and
The
if the
same number
value is
of rows as the data frame.
same number of rows, and if the value is true, I want that row. If the
And if
value is
it's-
false, I don't want that
And if it's not the same number of rows?
row.
Or it's fine if it's not the same number of rows. Meaning if it's not this, the row indices, whatever length of row indices is, the resulting data frame would be of the same length.
I think they're talking
We were
about
talking
the
about
filter,
boolean though.
the bool filter.
So same logic. Whatever length of bool filter is, the resulting data frame would be of the same length.
What if
But bool
which-
filter's length
which
need not
rows
be the
does it map
same
to?
as this
No, but
length.
you mean number of ones in that filter, or like is it like
Yeah.
the bool filter kind of sounds to me like if I put like 101, I will get the first and the third column. That's
Yes.
kind of,
So what if I give you a
The
bool
first
filter
filter
that's
is
literally 1-0 in a loop forever? Basically, I want alternating rows.
Yeah, you would get half the data frame back.
Will eventually terminate.
Yes. Yeah.
Okay.
Sorry, Levi, can you summarize for me? I didn't
So
understand.
if I give you an IEnumerable of bool that literally just yields 1, yield 0, yield 1, yield 0 forever, like, will it terminate?
Oh, actually, that may not terminate. It would throw when the index becomes more than data frame's length. Then this is length.
And if I give you an enumerable, if I have 10 rows and the enumerable is just false true, my resulting data frame will just have
One
a
row.
second row, and
Yes.
that's it.
Yeah.
this all feels to me like they should be directly on the columns or rows kind of. I don't know. Do you have a row property?
What do you think of adding a slice method as this? There's just a lot of stuff going on in the
There's
indexer.
a filter method that takes those parameters. This is like a convenience thing on the data frame itself. You can also do df.filter, and that would do the same thing.
Why filter instead of where?
Um,
Because that's what people in .NET are familiar with for, like, link, for example. You filter
Presumably,
user-
it's what Pandas uses.
So by the way, the filter method takes a column of bool, a column of int, a column of long, as opposed to an
right, it does the first three that's highlighted here. Why? Actually, I'm not sure if Pandas calls it filter or not. We could call it, where I don't have a strong reason to like keep it as.
Yeah, I mean, my general guidance here would be similar to what Tanner's suggesting: is if there's an existing name for it that's prevalent, then use the existing name. Like in the field, if there's existing name, use that. Otherwise, use the name that's most prevalent in .NET land. Which
Okay.
Do people get confused when it's named like where and or filter, which one you're filtering or conditioning out? Like it seemed like there was questions about, am I picking columns or am I picking rows?
Well, I mean, the way where works with IEnumerable is it doesn't really take another IEnumerable. It takes a predicate that you can then use to filter true or false for every, so it iterates through all the elements of the IEnumerable or the data frame here, and then you just filter using your predicate saying, yes, take this one, or no, don't take this one.
But the point is that in LINQ, in IEnumerable, it's one-dimensional, but here we're two-dimensional.
But from what I've heard, once we get rid of this, the string column name one, all of the indexers are row-based. Right.
Except for the top one.
Right. I would think that by default you would enumerate through rows, since this looks to be row major, and then there might be alternative names for saying filter down on the column.
Yeah, I think this is kind of opinionated. Like the people who use it for some longer period of time, they will kind of know it anyway, and like they kind of think about like new users, which like if I saw this code, I would not know if this is the first time I tried. That's kind of. I'm not like super. I don't feel like super strongly about it, but I feel like it's better to just make it explicit columns something rather than like the generate index. Like I get the two-dimensional kind of indexer. This one I totally get. This is I don't have objections on this one, but anything else feels weird kind of to me. I wouldn't know what I'm interpreting unless I actually like in VS, if I got the IntelliSense kind of telling me this is wrong, I would know that. But if I was reading the code on GitHub, I would no clue.
I mean, it consistent with the way .NET exposes multidimensional data in general. So,
Well, I think as soon as we move it into a separate method and not an index, make a little more sense to me. Another thing
The reason for the
have a
indexer
proxy property called rows have indexers.
Yeah.
Yeah, the rows one I've been keeping on the back burner for a while. I won't delay it as much as I can.
Also, kind of as a side note, perhaps instead also might be worth adding some kind of range of rows since this is a new thingy, so you can use the column.
So are we saying remove all indexers?
Except for the two-dimensional ones, I think, which is here.
But,
I mean, no, I mean, I'm not sure what the right answer is. This is the kind of thing where I think there's probably a disconnect between trying to understand the APIs and the code that like is concise that someone might want to write. Like, these were all, some subset of these were used in your examples, right?
Yeah.
Which ones?
There's a filter, I think. So if you go back to the example MO, the primitive data frame, the IEnumerable long, the primitive data frame of bool, I think. So if you scroll up, a little more, stop there where it says dot element wise equals 1. That df, so line 98, df dot filter and then ispr dot element wise 1, that returns a primitive data frame column of bools. And then it's a filter over the column of bools.
Yeah, but you're using the filter method, not the indexer.
Right. The this of that indexer calls the filter method. It's really just a wrapper around this thing.
Wait, with the this of which indexer?
The this of the bool indexer calls the filter with the bool parameter.
So basically,
But this isn't using. Sorry.
So get item and filter are the same method. It's just they used filter in the sample here instead of the item getter.
But that's kind of what I'm saying. Like, if this is using filter, then the natural thing for you to write was filter, not the indexer.
No, I mean in this case I was like showing code, right? But if I was writing it in a notebook, I would just be df. I would open like square braces and then write that stuff. I mean, it's really if I wanted to use the method or if I want to use the indexer. Like on a notebook, I would tend to write as short code as I can. Right.
Notice the indexer that you are using here is always by the column name, right?
Yeah.
Like what we're saying is get rid of the one that we wanted to use all over here. The df of is PR.
Well, that's I guess what I'm saying. Yeah, my initial comment was it was weird to me that there were two different kinds of things being returned. Based on this sample, I would get rid of all the ones that return rows and just keep the one that returns columns.
Yeah.
But you're telling me as well that this isn't representative?
Well, no, so there's an indexer by row on line 114.
Right, that is.
No, that
But it's in the
only-
column.
That's
that's
in the
a
column. It's to a column.
Oh, sorry, it's an indexer on the column, not an indexer on the data frame, you're right.
Wait, so repeat the question on 98 again? I'm not certain I understand.
based on this sample, the only indexer that should exist is the one that takes a string column, and get rid of all the ones that return rows. The disconnect for me is having an indexer that sometimes returns rows and sometimes returns columns.
Yeah.
This sample shows only using indexers when it returns columns. So based purely from the what code does someone write perspective, based on this sample, if it were me, I would want to just have the column indexer. But I think you're also telling me that this code was done for the purposes of showing API rather than for the purposes of showing what someone would actually write.
Do you have a sample where you're using any of the row indexers?
Yes. You have to go to the unit tests. So Emil, if you scroll up to the top,
Would the unit test be representative of what a real-world customer would write?
I think so.
Okay.
Yeah. Scroll further to the top. You need to go back to like a different file itself.
Oh, different file.
Yeah, and then hit that guy. Then DataFrame tests, just last but one. Then scroll down more until you hit the first fact. Keep scrolling. Okay, there we go. So this one, yes. So this one shows. First one is the row and column. Line 189, you actually get a column, and then you go to the first index on the column. 194 is calling the set method on it, and line 203 gives the data frame of int5 gives you the column called int5. Which in this
But
case
none
is,
of these indexers are giving back rows, right?
I pasted a sample chat, same one that I used last time. Can you
This
pop
one.
that open, Emo?
This one does, right?
no, that one gets the column and then gets the row one in that column. So the error key sent you a sample.
Isn't it's always row then column, right?
Yes. So that one's there's braces close. The tail stuff 4 would give you
Would give you the
oh,
fourth
sorry, that would
row
give me
in
the
tail
row.
list.
Yeah, that would give me the row and
That
then
kind of answers
yes.
the question if this is confusing or not, I guess.
Well, it's consistent, and then it's always row.
Yeah, but
Yeah, it's always
still.
row first and then
Which is also what C, C++, C Sharp, Python, and the majority of other languages that aren't OCaml or Fortran do.
So this is a sample you showed us last time.
Yep. So housing data in this world is a data frame.
Yep.
And the first chunk is just, maybe we can delete it, but it's just basically shuffling an array of ints, right?
Right.
So line 13 is getting, from the row count, get from 0 to the row count, and then shuffle them. And then 14 and 15 is, 14 is getting that size, right?
This is
where
this is just an int, right? Or long, probably, right?
it's an int because we're casting it. Yeah.
I see. Yeah. And then this one is a data frame, I suppose.
Nope, this one,
That's still an int array.
That's right. We started.
Next one's also an int array, and then data.
and then the
frame,
last
data
two are
frame.
data
or
frames.
data frame. Yeah.
Nice.
Man, I hate VAR.
Well, I mean, I'm generally a fan of it, but like, if I have no idea what the syntax on the right-hand side
Because
means,
we're writing to
it
the
does
code
not
and
help.
reading
That's the exact point.
It is interesting in that like lines 17 and 18 are range-like, similar to lines 15 and 16. Because when we introduced slices and range, we introduced throughout the framework an idea of getting back not just elements from the indexers, but slices of the original data. So this does kind of fit that pattern. Granted, those slices might be discontiguous, but
Right? In this case, we actually do copy.
but I mean, like the array indexer, the array slice method does as well here. So
Oh, yeah, good point.
I mean, the other question I have is like if you, to me, this selecting rows by passing in a column or whatever, like, reminds me a lot of like the way we do masking with vectors as well, right? But usually we have methods that would tell you that this is what they're actually doing, rather than an indexer where you kind of have to apply some imagination to know what's going on.
I mean, we're kind of following a little bit of Python here, right? Like, a lot of this code is influenced by how people are writing pandas code in Python.
No, I get that.
That's why we have like this multiple indexer that does different things.
To me, the key question is, and I think that is something where I think the room has not a uniform opinion on, is like how discoverable and surprising are these behaviors, right? Or I guess the better question is, how intuitive are these behaviors, right? Like, I mean, it's a bit hard to say when you just stare at an API surface, right? You kind of have to actually write some code and see what you actually can reason about when you actually call APIs and see what you're getting back.
I mean, so rewrite like say 17 to where? I don't think that makes sense either, to tell you the truth, right? If housing data dot where train rows.
Well, I mean,
yeah, because you expect a
right?
predicate
Like, I
going in
guess
there.
I wouldn't.
I'm not suggesting that particular method name. All I'm saying is that sometimes when you just have a method that has a verb in it, it tells you more what the API is doing. Right? I'm not convinced that where is necessarily better. It's just that it avoids the problem that you have just an indexer, and then if you don't know the types, you have no idea what the thing does.
Yeah.
Maybe as a
Selected
compromise, we should have both. That is, we should have the friendly named methods for people who are familiar to .NET code, and for people coming from Python and pandas and other things, we should offer the indexers. And there's no more implementation costs, but there is potential for a little bit of confusability when reading code.
To tell you the truth, I'm not convinced that this makes the world a better place. Like, I mean, the canonical example of this is PowerShell, where you are allowed to use the short aliases and the long forms, and everybody does everything all the time. And so you have this super inconsistent world where you cannot reason about any line of code anymore. Like, I'd rather we pick one convention and just use that consistently, rather than having two different conventions, and then you can use both of them at the same time. Like that, I think.
Well, I mean, that's exactly what the operators do, right? We haven't got into operators yet, but when you want to add two columns, right? It's like there's going to be a .add method, and then there's going to be an operator, and it's going to be the exact same.
But that is not so much to enable different coding styles. That is more to accommodate different programming languages that don't support operator overloading, right? I think I would not expect somebody who does, let's say, a vector multiplication in C# to actually call the methods. I mean, you would use the operators. Like, that would be idiomatic C#. I mean, nothing stops you from using the methods, but I mean, who has ever done, like, methods on mathematical operations if you could have done the operators, right? It just reads so much easier.
But wouldn't that be the same thing? Not every language necessarily has overloaded indexing support, so...
No, it's part of the CLI. You have to. Like, sorry, common CTS. You have to support it.
You have to support one indexer. You don't necessarily have to support.
You have to support overloading indexers. Yes.
Cool.
We have not, like, otherwise half of our collection types wouldn't work, or a good chunk of them wouldn't.
In my opinion, the indexers here are the exact same. They're in the exact same breath as the operators, right? Like, it makes the code more concise to read and to write.
Yeah, I buy that. I mean, like, that's what I'm saying. To me, the problem is I have not used pandas, right? So I don't have the feel for the intuition. And that's what I said earlier. Like, when I just look at an API service, I'm more with Steven on the, oh my God, I don't think I can reason about what the indexer does, because it does. It's basically the Swiss Army knife of things it can do, right? And I can see if you're used to pandas that you will find this intuitive, but I don't have a good handle on, unless you actually use the API for like a week to actually get a feel for how surprising I would find this.
Yeah, there is something definitely to be said for somebody who's steeped in this world finding these APIs familiar, because they're coming from pandas, or even if they've never even if they don't use it as their primary thing, maybe they have to interop with it at some point.
Yeah.
So having similar syntax is a benefit there.
I mean, that's something we can totally check for in a usability study, right, and see how people are actually successful or not.
Yeah, like for this specific example, I honestly think we should just rather have the range overload on the indexer of the data frames rather than going to 2 steps. Either way, this is the same program.
Yeah.
Yeah, I don't feel too strongly about getting rid of those indexers. Like it might actually make it easier to use depending on the target audience.
But you can always add them.
Yeah.
Like if we don't add them right now.
I mean, giving it some more thought, like I think I retract my earlier statement that having both conventions is bad. I think both conventions being bad is most applicable for naming conventions. I think for shape, I think it makes more sense because we have that in other places, right? The most recent one I can think of is the collection initializer syntax, right? People who use JSON, for example, almost nobody that we saw in the ability study actually assumed them to be, consumable with collection initializers. But once you can, it makes your code really nice to read, right? And I think that might be the same area where it's like, well, okay, when I'm new to the API and I have named methods, okay, now I can reason about what things does. But once I'm actually proficient with this, I actually like the fact that it's super concise too, if I really want to, right? Maybe that's okay.
If I want to filter down the columns rather than the rows in my data frame, how do I do it?
What does that mean, though?
Columns
Filter down
down
the
or
columns.
I mean, I have a data frame that contains name, age, and address, and I want a data frame that only contains name and address.
You cannot do it at the moment. You have to make a clone and then remove the column you don't want.
Can pandas do that, or
No.
people don't do that generally? Is that what you're saying?
Yes. Well,
wait, do you want a new data frame, or do you want to edit the data frame that you
I want a
have?
new data frame.
So you could say there's a data frame constructor that takes a list of strings, a list of columns, right?
that's true. Yeah.
Granted, they would share columns if you did that.
Yeah, I think what Steven is asking is more like, what's the equivalent operation where I pass in a column with a bunch of bools to get basically a new data frame with a set of rows selected? What would I do for columns? It seems odd that you do a completely different thing for that.
But the thing is, people generally don't, like, you generally are operating on the rows.
Right.
Right?
Usually you have more rows than columns.
I understand.
I mean, even the fact that we have a .columns property, right, but we don't have a .rows.
I mean, to be honest, like a more .NET-y way of doing this would be you pass in a delegate, right? And then it's like, whether you have the delegate run over the rows or the columns is pretty much irrelevant, right? It does the same thing. And then you just have effectively a, give me a new data frame where you evaluate this delegate over all the rows, and then that's the rows I'm getting back, right? Or here's a thing that runs over all the columns, and that's what you get, right?
So a thing about this, right, is the shuffling, right? Like the train rows are they're randomly shuffled 90% of the rows, right?
Yeah.
How do you do that with a delegate? How do I say I want row number 3, and then I want 5, and then I want 2?
Well, I mean, the delegate will be more equivalent for the primitive data frame column of bool, right? I think for the one that takes in India, that would be harder to do. But same thing, instead of returning a bool, we would return an int from the delegate, right? That would be the...
Because we had talked about this at the last meeting, because one of the things that I suggested was you could avoid that and just say there's an 80% chance I choose any given row. But Eric had brought up a good point, that you want the rows to be randomized as well, not just random. You want the order to be randomized.
Yes.
Right?
But is shuffling basically the only scenario where you want to do that? Because like if this is the only scenario, you might just expose shuffling.
I mean, we should put a shuffle method on list of TN.
I mean, you could filter by whatever you want, which would act as a shuffle. You're not really shuffling or filtering, but it's the same operation.
We sort. We have like a sort API, right?
Right.
The way we implemented underneath was got the indexes sorted order, and then said select out those.
The sort kind of makes sense. Then they pass the shuffling sorting or whatever.
Yeah.
So yeah, it's not necessarily just shuffle, right? It's any time I want rows in a certain order.
Right.
Yeah.
Okay. Go further.
Perhaps you did an order by using your own.
So what did we decide? Are we going to leave? Are we going to take out the column indexer, but leave the row selecting indexer? But then also we're going to rename the filter method that it calls?
I don't think we made a decision. I think most of the time, like the problem with API review is like we can point to a thing that looks smelly, but it doesn't mean that we have an instantaneous solution to the problem, right? I think the smell that Stephen raised, which I buy, is that if you look at an indexer, especially when you look at the original code where you only have bar on one hand side, it gets tricky to reason about what the thing does, right? I think if you look at, like, one of the things we talked about like a few weeks ago was when operators are okay, right? It's all about your intuition. Like, I mean, if you do A times B and it multiplies, okay, that's great. But if it's like, oh, I'm doing this fancy, every other row masking behavior, it's like, well, but all I wrote was A star B, right? I mean, like, how do I reason about things like that, right? And if I index into something, people can reason about that. It basically gives you logically an element, right? And then, sure, depending on what the type is, it's a row or it's a column or it's an element, but if you have all combinations and then slices thereof, like it gets harder to reason about this, right? Because now you have to really understand every data type that you pass to this, because depending on the data type, you do drastically different operations. That seems smelly, but at the same time, again, like I would like to see someone usability study doing things like that and then just see how they fare, right? Because it's possible that when you're actually in the trenches and you actually compose stuff, it feels very natural that that's the way you do it. But I agree with Stephen that it looks very odd.
The uber smelliness here is the polymorphic indexer.
Yeah.
Like, use indexers for like one type of thing. I think that would be okay to move the column selecting indexer to the columns property, right? So anytime you want to select out a column, you'd say dataframe.column sub this name or index or whatever.
Yep.
And then the indexer is either only selected a specific cell or rows in this case. Like, is that still too polymorphic though?
So
if you go back to the
the rows
indexers,
on the data frame and the columns, move all of the columns indexers into the columns connection.
I mean,
right? There was only one column indexer.
Yeah.
Right.
I don't think the existing indexers would smell too bad, because if even the indexer that returns a single element, the A comma B indexer, you would still get to the same thing by doing bracket A close bracket, bracket B close bracket. So you can kind of reason that that's basically what you wrote. That doesn't strike me as terrible.
I would think the one benefit to moving to having the indexers on the data frame only select an exact cell and then having the row-based ones move to a row collection to match the column collection one would be that it would allow the internal implementation to change if that was ever deemed to be desirable in the future, to where a column major implementation was more efficient.
So this is always column major, FYI.
It's row
This
major.
data frame.
I mean,
no, like all this data is columnar. It's stored in a column, each column. So column 1 is all stored contiguously. Column 2 is all stored contiguously.
Right, I think Tanner says the API makes it look
I think
like
by
it's
major
row
he means
major.
like what do you specify first when you index?
Right.
Rather than
No. So row major would be like in a standard image, you have x0, x1, or x0, y0, and then x1, y0 all the way over, and then y1 starts the next row.
Okay.
That's row major, and that's the default C, C++, C Sharp, everything else.
Right, no, the
I
data
actually
here
think
is
the-
column major.
I actually think it might be reverse, like many times, but I have seen both, so
I mean, the actual data here is column major. It's just the APIs always take the row first. Because even if it's column major, I don't think anybody would want to write column, comma, row. Right?
Well,
At least I didn't think that was natural.
X and
that's all.
Y is exactly the scenario, like when you have literally the image picture. The X goes first and then the Y goes second, so that's the...
Yeah, and that's still row major.
No, but we're
Yeah,
talking
I
about
understand you're
different-
storing it
Okay.
column.
Yes, yeah.
The other,
But in general
so-
math, the columns are first.
So one interesting thing about that is there is a disconnect in the API surface right now because I instantiate a data frame with an I list of column,
Yes.
and then I access the data frame indexer, and what I get back is not a column. What I get back is a row.
Only so in my head, maybe because I've looked at it for so long, it's clear. But if you give one index in it, you get a row. If you give an array of indices, then you get a data frame.
So a data frame is a collection, correct?
Yes.
I instantiated the collection with an I list of T.
Yes.
I now call the indexer on the data frame collection, and what I get back is not a T. What I get back is an I list of object.
That's why.
But that's not fair though, because you instantiated it with an I list of columns. The indexer, you're doing the indexer with one index, so you're getting a row up.
But that's what I'm saying. Like basically, like the problem is when you think about it as a collection, that picture makes no sense, right? Because
But
basically,
it's a 2D collection, right? It's two dimensionals.
Yeah.
yeah, I think the problem is like if you think of data frame as housing the data, you may actually go down a certain path. But if you think of data frame more as a collection of columns and the columns themselves hold the data, I think things start to make a lot more sense.
Right.
But the API service is not necessarily communicating that, right? Like that's, I think, part of the problem.
Can we go to? Can you show the API surface and explain it more concretely?
Oh, sorry. Yeah, like that. When you open Windows.
So you.
Or let me do one thing.
My
really
assumption
quick
is
here.
the expectation is if a constructor takes a collection of something, I assume I should be able to index into the constructor of this thing. Is the indexer into that collection that I took? Is that where we started?
I think that's kind of the mental model that you have for collections.
I just threw it out there. I don't feel strongly about this. It's just if you think of this as a collection of column, because the constructor takes an I list of column, then it would be natural to think of the indexer as returning a column, not a row.
Right, but the property columns is the collection of
Yeah.
columns, right?
Yeah, that's why I'm.
Would it be dumb
that's a big argument.
if we change the constructor to take a data frame column collection?
Yeah, we could do that.
I'm just throwing that out as like as a potential way to mitigate that.
Actually, it solves
But-
that problem.
I'm not saying we have to. I'm just it makes it more obvious.
Would it make sense to have a
Switches, right?
roles property?
The reason postponing it is because it's very hard to get a strongly typed rows property. It would be just a list of object.
So that as kind of like a proxy object.
Well, this was Tanner's earlier suggestion.
Yeah. I mean, you could imagine that it just literally returns a struct, right? And then the struct, basically the only thing it holds is basically reference to the data frame. So basically you can say rows.count, and you can say rows bracket, and then actually index into that, right? Like you wouldn't actually store any data in it. You would just make it so that API-wise it makes,
We're just calling
it's just, yeah, you basically have rows and you have columns. And then basically you end up in a world where the indexers on data frame always give you back a data frame. and then everything. I mean, the only exception might be the one that takes both a row index and a column index, and everything else is either off the columns or off the rows.
Okay. Yeah, I don't have a problem with that. Yeah, we could just move the row indexers onto the row collection. Got it.
I still don't fully understand what type is the .rows property return.
Like a rows class, I think they mean.
Well, I mean, like
A data frame row collection.
yeah, you can either do that or you literally just have a super primitive, just you know, a very cheap wrapper around something that basically, because internally you probably don't store anything on that collection, right? You just have it elsewhere. Just from an API standpoint, it makes more sense to say, you know, you say columns.count, you say rows.count, right? And then the indexers for rows and the indexer for column gives you either a row or a column, right? And then everything else is just either an element value with the twofold indexer or the entire data frame, right?
Okay, yeah. So you're saying you make a row collection only that this long row index goes into that collection, and then this string column then goes into the column collection.
Yeah.
And everything else makes sense.
Yes.
Okay, cool.
What else goes on this rows class?
I think just that.
I think just these
Well,
two
he
things.
said row count.
Yeah, we'll probably move the row count to it as well, right? Yeah. I think we already got rid of column count, right?
Yeah.
So it's got a count, got an indexer
Yep. That's
that
it.
takes. What does that indexer take? The long row index?
Yeah.
I think so.
And then that returns the list of object.
Yeah.
I think so, yeah.
Do we still have the indexer that takes a row index and a column index?
I would probably leave that on data frame because this one is basically the matrix of both of them, right? So it makes sense that it's on the data frame, not on either rows or columns, right?
Yeah.
And then the column name indexer obviously moves to the column.
Yep.
And the filtering.
And then everything else is just dealing with the whole data frame, right?
Right, all the indexers in between stay here.
Yeah. The only suggestion I have is, would it make sense to rename the very first one that takes the primitive data frame column of bool to rename this to row filter?
Yeah, I think so.
Okay.
Then it makes
Same for the last one too.
Yeah.
It takes an INU bool.
yeah, that's a good point. Like bool filter doesn't make much sense, yeah.
I'm guessing also like the load CSV overloads and stuff. Whatever takes the byte array probably should take any marble.
Sorry, what?
The
And
type array.
whatever takes like the string array or type array or whatever array probably take.
Probably not. I mean, it is going to be a fixed length, basically. May as well just.
Okay. Go ahead.
Yes.
Okay. So the from arrow record,
Yes.
from arrow record, arrow string record, or whatever that is, from arrow record batch. So that one is a static method. It's not actually. So this was part of the attempt to like move arrow stuff out of the data frame.
Right.
Right. Okay. So yeah, that just takes a record batch and it does a zero copy and gives you a data frame out. The load CSV stuff, the first one takes a file name, the next one takes a stream.
Hot takes on this.
Okay.
So first off, there is a little disconnect here. But first one takes int num rows. Second one takes long num rows. I assume that was meant to be long in both cases.
Yes.
Okay. Also, you take a stream instead of a text reader.
Take a string instead of a text
A
reader.
stream
Yes.
instead of a text reader.
Okay.
Why?
I believe it had a text reader, and then I believe one of the comments on the PR was the stream is more typical of API, so I made it a stream. Internally, it actually wraps the stream into a text reader and does that work.
I mean, we very often give you both.
Yeah.
It's like
So one thing this thing does is it like if you look at the number of rows to read in the guess rows,
Yeah.
well, maybe not number of rows to read, but the guess rows, it actually goes over your data twice. One is to do inference on what are the types,
Yeah.
and then another time to actually load the data and go. And so the CSV stream actually has to be a seekable stream to go
Got it.
back to the beginning. Can you do that with a text reader?
No,
I don't know.
no,
So
you cannot.
Based
There's
on the
no.
position.
It's forward only.
Oh,
All readers we have are forward only readers.
So that's one potential.
Yeah. I mean, some streams we have are forward only as well, so just not.
Right,
Yeah.
but
So
that's why
you
we
would
throw
query
almost out
seek
of
and then
sequels.
throw.
right. Yeah, with throwing. Yep.
That's interesting.
I don't know how to fix that, to tell you the truth. Like,
Yeah.
it's kind of a nice
Yeah.
feature that it does do, inference of the data types, but it does makes it a little bit funky.
But why does it do the inference over the data rather than the resulting data frame?
Because
You need to know the type of columns to
to
create.
make the column.
right?
Yeah.
Yeah, but you can also
Oh, you
easily
infer the types of what you're saying,
infer
I
the
see.
type wrong.
Well, it's using 10 rows to infer the type, correct? That's
Right.
what guess rows
Right.
is.
Yes.
Right, but you could have 10 rows
True.
which are integers, and then the 11th row is
Yes.
it has the fractional
In
portion.
which case it would throw, and then it's on you to use the type data types thing in the constructor.
Sure.
It's basically
That
a
makes
time
sense.
bomb in your contract.
Yeah.
Yeah.
But other questions like the first kind of thing which creates DataFrame is called from arrow record batch, and then it's called like load CSV instead of like from CSV or something. Kind of consistent, like either with from or.
They do two different things, right? Like, from arrow record batch, it is a zero copy.
I see.
The data is
Right.
not
So it's-
copied.
I see.
Where the one you're loading from a file is obviously you're copying the data into memory.
Yeah.
How do you get away with a zero copy here?
Because we use this exact same in-memory structure.
Oh, we literally
if you
just
go
wrap the
back to
memory.
remember at the beginning when we talked about why it's stored as a memory of byte.
Perhaps it should be like
Just
something
because
like
that's
cast
how-
in the record batch itself. I
see.
don't know.
It almost seems like what you want instead of this from arrow record batch API is basically an API that you can, like, I don't know, in some suitable.
Maybe just constructor, no, or just make a cast on the record batch itself. Record batch cast.
Yeah, I mean, I would try to. I mean, record batch is an API from arrow, right?
Yes.
So what I would probably do is I would introduce a generic API that deals with memory of byte, basically. Put them in either, maybe not direct on DataFrame, maybe in some suitable place, like a marshalling-like API,
Yeah.
and then have another package basically that integrates record batch with DataFrame, and then this way you can just, have a public API you can call.
So let's explore that a little bit. Like,
Yeah.
so are you saying remove the dependency on arrow from DataFrame and make a new package?
It seems weird to me that we would have something like a fundamental data API that has a dependency on a third party. Because there's difference between dependency in memory layout, right? We have the same thing in .NET for, let's say, pinvokes, where we call it flat C API or something, right? But we don't usually like ship with like transitive dependencies in APIs, right?
Okay, how about
I think that was one of the
about the
suggestions
iData
from
view?
last time, yeah.
how about the iData view?
I think that's fine because that's basically BCL component, right?
I mean, not really.
I mean, that's how we promoted it.
Yeah. Yeah, I mean, if you remember, we tried to move it to the Microsoft.data namespace, and then it got shut down and it back to Microsoft.ml.
Yeah, I mean,
I think I'd be fine with keeping our dependency on Microsoft.ml.dataview like that to get the iDataView interface,
yeah,
and then moving the arrow APIs out into an extension pack.
yeah. I think iDataView like seems harder. First of all, it's harder to remove in an interface implementation, but also, I mean, logically, that was the idea of that type, right? To basically be this generic data representation, right?
It was, yes. And
So-
it still sort of is. I mean, we did split it out into its own package, so there's no other ML.NET stuff in there.
Right.
It's just what's needed for iDataView type. So instead of like an extension method off of record batch, like to DataFrame,
that's probably what I would do. I would probably have, wherever the integration would live, you would define an extension method on record batch. I would probably call it as rather than to, because to usually implies a conversion that is non-cheap,
Okay.
versus this one is like as is usually done for things that are supposedly O1.
Because there's also the inverse operation,
Right.
if you go lower.
Yeah, I mean, you
I
would
have
probably
a
have
DataFrame.
one extension method defined over record batch and one defined over over data frame, right?
To go to the keys, I think.
What is it called? Azure, not arrow.
Record batch.
Two-way.
Yeah.
Oh.
Funny enough, though, yeah, that gives you back an innumerable record batches rather than single one, I guess.
That's related to how the record batch itself needs to be in memory. It has to be of the same length,
I see.
but it only takes a memory of bytes. So if you have a column of ints and decimals, then stuff changes.
Right.
I
I mean, the other advice I would have is like based on what we saw previously, I would not do overloads like this.
Take an options object.
Yeah, like we have relaxed our stance on optionals in the framework design guidelines, right? But like the problem is people don't understand optional at all. Like we had like the Azure SDK did this thing where they had, I forgot what it was, one of the client APIs, basically the core API you have to instantiate to talk to a service. It took like 10 optionals or whatever for the various things you can configure.
Yeah.
I think 8 out of 10 people tried to pass every single value. They did not understand that they were optional.
Okay.
Now there is a problem in the IDE probably. Like I already started the discussion with the IDE team that like the brackets thing is very subtle. Like you kind of have to understand what the bracket syntax means in order to see that they're optional.
Okay.
But people don't understand it and they try to like construct the whole thing, right? And then like
You'd be okay with this and an options?
so what I would probably do is I would probably like try to have an overload that takes, you know, as few arguments as you can get away with.
Okay.
And then I think if you have 2 optional arguments, that's fine.
Okay.
But like try to get to something really minimalistic. And then if you have one longer one that allows you to do everything you want and has some more things that are optional, that's also fine. I mean, that's more for the advanced user. But like basically what people will do is they will try to find the shortest overload.
Yeah.
And so if that takes 2 optionals, yeah, people fuck it up and they still pass it in, that's okay. But if the shortest one they get is like 10 optionals, then if they try to pass them all in, like there will be a lot of time before they can actually get
Consider
the API being called.
Regardless of whether you have a giant overload or an optional or something like that, also consider taking a system type as a parameter. Because all of our APIs, like file.readAllText, for instance, take it.
Okay.
You can pass a null.
Right.
The other thing I would recommend to make the type array kind of not optional and instead add some kind of utility to guess what the type array should be. So basically kind of like guess types or something like that. So and this because like right now depending on the data you will kind of have a type bomb which will kind of work in your code and might stop working in the future depending on the data you will get. So like exactly the example Tanner said, like you have like first 10 rows of some data and then the next several rows which are completely like larger or like different type or something like kind of like more extended.
Same type but different format.
Yeah, so you will kind of like people will kind of use this overload, don't pass any arguments. It will work for like I don't know, like several days, and then basically they ship, and a few days later, like they get different data sets with different data, and like basically blows their app, and they don't know what.
I mean, this goes kind of back to like, what is this API for, right? I mean, I would argue say it's similar to encoding, right? You should always specify an encoding, right? You should always specify a format, right? But in reality, there was people write out or throw away code, right, in the scripting environment. Like, what are the chances that type inference will just work for me, right? And I would argue if you look at the first 10 rows, fairly high. I mean, you know, Excel does the same thing. It looks at the first, what is it, n rows, and I almost never have to tweak like the data types ever in Excel. And like, it's if it works often enough, forcing people to write like 10 lines of code to guess some types defeats the point of the API, right? The whole point is that you're in some interactive experience. You just want to load the data as fast as you can, like inspect it, slightly shovel it around, and then like do something with it, and maybe you throw this thing away like 5 minutes later, right?
Yeah.
I mean, that seems like a good candidate for let's try to opt for something simple, and then if you write production code, you probably should not use type inference, right? But like that, honestly, I think it's the same as any other API where if you let the system guess for production code, that's probably not great, but you provide a lot of experimental code as well.
And I would think that the most common case is likely issues between integer and floating point. And for that case, you could start parsing as integer, and then if you hit floating point anywhere in the column, you could just convert.
Yep, and that's exactly what this does. But well,
No. I mean, like if
Today we always use floating.
if you analyze the first 10 and you say it's integer,
yeah,
and then you start parsing the real data and it becomes floating point, you could say don't fail, instead convert the rows to floating point.
okay,
Later, basically.
right. Yeah, I should have responded by saying I didn't want to do that. So actually now it's any number you see is now a float. So if there's actual decimal,
That's even worse. Because floating point is non-precise for all integral values, and so now you're introducing rounding errors and other points of failure in code where the user may not want. So like if you're doing indexing and you're using integral values as the key,
I feel
anything
like every
over
single heuristic we had ever in the code was always causing a pain in the long run, so I would say make it explicit. And then like later you might add something that makes sense.
To be fair though, if you load a CSV file, right, if the data source was floating point, even if the numbers are integral values, they will have a 0.0 suffix usually. Like I think that I don't think you can fuck this up too bad in practice. I mean, yeah, if you have a handwritten CSV, maybe, but like if you get the CSV from any sane data source, like I don't know why that would be a problem.
As long as the exception is
if you're creating the CSV file using .NET and you're using round trippable strings, then things that have less than 6 digits will not contain, and no fractional portion will not print with a .0. They print as the shortest string.
And the problem with CSV is so easy to generate by hand, like people do that.
Well,
I mean,
Like,
and at this point, I just argue saying, well, if you really wanted the decimal types, then specify the data types. If not, then be happy that
perhaps maybe add another overload like heuristically load or something to make it kind of clear to not use it in production.
Well,
But I have mixed things.
Or I mean, I think the only sane thing is you start off by saying everything is int by default. If you ever come across something that's long in that data set, then you extend the data type. If you ever come across something that's float, then you cast the data type. So therefore, you have inference. It matches the normal C# in .NET inference that most people are used to. And worst case, you might have slightly slower inference because you have to recast some types up, but most of those are single instructions and very cheap to do. And users could avoid that perf penalty by explicitly saying the type.
well, I think the problem will be that you have to reallocate the column, right?
right, it would be a new column,
I feel like
Right.
reallocating is better than having
Then-
Oh, for sure. Like I mean, I think honestly, I think it's completely okay to say inference is not the fastest way to get the data. I mean, like at the end of the day, like I don't think people will do this in production code if they're the same, right? So that means if you care more about performance, if you care more about reliability, then you're passing the types and then things are faster. If you're in an interactive environment, who cares that it takes 5 nanoseconds longer
Right.
because you probably don't load a 100 gigabyte file either, right?
Yeah.
You probably start with something more in the realm of like megabytes.
Even if it
probably
was
less than
100
that.
gigabyte, you'd probably notice the because you reallocate upfront, right? So that.
Yeah, it's probably also. I don't know. I'm inclined to believe that. I don't know. I don't know how many rows you look at. You said 10. Like,
you could change
how often?
that,
How
yeah.
often do you get this wrong? Right? Like, I mean, if you have to continuously reallocate, maybe look at the first 100 rows, right, and then.
Random 10 rows.
Well, that might be harder in this forward-only reader, but yeah.
Oh no, I accidentally read the header row.
Let's go ahead.
Operators.
So the
what is-
real only change here is options.
Yeah, make it an options class, or at least have an overload that is shorter. That basically, maybe you have one that just takes the file name and the stream, maybe, right?
Yeah, and
Okay.
if also add the encoding property to the
Yeah, add an
optional class.
encoding one. Yeah.
Yep.
Okay, that's the wrong one.
I left a comment on the API review website as well.
Okay.
Okay.
The wrong one.
That wasn't a quick review.
Yeah, I know. I have too many windows open. Not that simple here. Is that the one? No, that's the one that's
Don't
on my
worry,
screen.
Windows Identity, we're coming for you.
Where did I find my notes now? Here are my notes.
So we removed all the comparison operators and we made them element-wise blah methods.
Mhm.
Yep.
Yeah,
People satisfied with that? Is
I think that makes
decent?
sense. Yeah.
These are just the operators for that.
So what does it mean to have stuff like operator plus bool or char?
Right. So this is so operator plus for bool obviously doesn't make sense, but for the others,
Well, you listed it here.
Yeah.
sure. I agree. This,
What does it what does it do?
3 plus 2.
it'll just throw. I think this thing just throws.
Okay, that's odd.
We should probably remove that.
Yeah, we should remove bool.
Anyway, you were saying, yeah.
But for the rest of them, it's just addition, but element-wise for each
Sure.
element in the data frame.
Yeah.
And then the same types on the right are defined for plus, minus, division,
That makes sense,
multiplication, also modulus, I think.
So for things like and or, do
Yeah.
you not expect bitwise being able to take in things like int or long? Is it just Boolean?
For now, yes.
Is this actually like really your scenario? Would it make sense to instead kind of overload the and is it even possible to overload the
Column?
end?
I don't know, actually.
I don't know.
No.
No,
And
because
this
you want to do all of them.
Does it even make sense to have those? I'm just kind of curious how useful that is.
I don't expect that many people will actually use this on the data frame itself, but the same thing are also defined on the columns, which
Yes.
I expect people
Which
to
makes
use.
sense.
Yeah.
So the data frame, it makes sense if all of the columns are the same type.
Exactly,
basically.
yeah.
Sure.
I mean, ish.
Well,
I mean,
yeah.
if it's a numeric type
So-
and you add a float, that would work. Yeah.
Yeah, sure,
So
whatever.
presumably, like if you have a because the operator which works on bool, presumably the data also has to be bool, right?
For the bool one, yes.
So like if my array is only trues and false, right? And I do AND with true, it will produce the same result, right? And if I do this with 0, it will always produce the 0 of the whole thing, right?
Mhm.
Yes.
So in both cases, it kind of doesn't make sense to have it.
What do you mean? Maybe that's the operation you want to do.
It will turn your entire data frame into true or false.
Yeah. Maybe that's the operation you want to do, right?
No, it will either not do anything or it
Maybe
will
it's not a
zero
hard-coded
it
true
out,
or
which-
false, though. Right? Maybe it's I did some operation that
Yeah.
made a Boolean.
Yeah.
And now
Yeah, but
and
you
everything.
can use the kind of if to then do something, then else do something else, right? And so you can zero it out or not do anything. Basically, the only case you care about is the false case.
Yeah,
in
but I
which case
can-
you zero it out.
But
which-
I can imagine if this is in the middle of a sequence of operations,
Yeah.
like maybe you just allow this to go through, and then at the very, very end, you check to see if the data has been zeroed out effectively. You don't expect it to be a common case, so you don't want to start putting if statements all throughout your code, but you do want to check once at the very end. Like, it makes, I can see that scenario.
At the same time, having and or for all overloads is useful because it allows you to trivially mask out a data frame. For example, you want to mask all not a number values out of the data frame because you don't care about them. You can trivially mask them to say, treat them as 0 instead.
Okay. Let's see. Again, I think last time we had this, I think the feedback may have been that only have bool overloads for the and, or, and XORs operators. So now we're saying.
So okay, I can see the
So now we're saying for the and operator also add the numeric types, right?
Well, I'm
I
just
think for
wondering,
all
does
of
it,
them.
do you want them?
Because like when a data frame is essentially a type of tensor, which is a higher kinded vector.
Right.
And vectorized code frequently does operations of all types, like ANDing, ORing, XORing, with other specifically for things like mask out this particular value,
Okay.
or transform this value to this other value,
Right.
globally.
Okay.
Yeah. So there are two pieces of feedback being given here. The first is on all operations other than and or XOR, remove bool,
Yes.
remove char.
Yeah.
because neither of those make sense. The second piece of feedback is for and or XOR, should you also allow other numeric types?
So I don't agree for char. People frequently do things like convert from lowercase to uppercase by adding to a char.
And you know what? When it gets automatically converted to an int, everything works just fine. Data frame plus single quote A, close single quote, turned into an int. All works.
What does dividing by bool mean?
Whoa.
Just curious.
That's yeah. That should all the bools should go for the plus minus multiplication and division. So this is like template generated. That's why the bools show up.
Will any of these actually change the type of the data frame that's returned? Like say that
Yes.
you have a data frame of int and you call
Yes.
plus float.
It would turn on the columns to float.
Okay.
But because we're returning a copy that users would not see that.
Okay.
Okay, let's go further down.
So basically it returns what the natural type would have been of that operation.
So
Yes.
we only have 50 minutes left. Should we talk about the package name for a moment so that we can, because I think that's something people wanted clarity on before we ship the first preview, right?
Okay. We not decide Microsoft or data analysis.
Well, I think that was the thing that we had in the beginning, right? It's like I think the name we decided on was Microsoft.data.analysis as the namespace, right?
Yeah.
And then the question now is this the package name and is that the assembly name, right? Or should we have something more specific? And basically, the question becomes, if we have more stuff that ships in analysis namespace, right? What package would that stuff go into? So, for example, when you factor out the arrow dependency, right? You kind of have to ship this in a secondary package, right? Otherwise, it doesn't make much of a difference. What would name the other one, right? I mean, maybe we just name the other one Microsoft.data.analysis.arrow, and then we just say this is the one where all the core stuff analysis will go, right?
Okay. The namespace.
Well, it wouldn't be, no, the other line would not change the namespace. The other one would still be in the same namespace.
Right. No, I mean, there's a lot of
Thoughts?
like indirection to get to the actual thing I want.
Anybody else, any opinions? Otherwise, I would just leave it at that.
Do we want abbreviated names for the doesn't matter? Better?
No, I mean more like for the namespace and the package name. If we are
okay.
fine with that, then that's
Sorry,
completely.
it's
Why
the
not
delay.
system dot, by the way? Why do we use system Microsoft dot?
Well, I think that was one of the things we talked about at some point. I think one of the concerns was that the APIs is not baked enough to be in system namespace, but like at this point for data, I don't think it matters one way or the other because we have both names in use today, and they both are basically used interchangeable. So I don't have strong opinions whether we put it in system or in Microsoft. It's just a toss-up.
There is the thing about system.data being very relational database.
Yeah, but there's also no SQL databases in it, right? It's like, I think system data all up is basically ADO.NET.
Right, which this is not. I mean, that was my thinking of pushing for Microsoft.data. Is it that exact thing that you just said, that system.data is ADO.NET?
Yeah, I don't think that will get you what you want though, because I think in the heads of most people, the difference between system data is just out of band versus inbox. I don't think people make it an assumption that it's different technologies.
Most people don't know what out of band and inbox are.
Well, you say that, but like I think that's actually not true for people that use Microsoft packages. Like I mean, there's like this long priority for ASP.NET, for EF, for stuff that we have shipped like HTTP client that use that naming convention. So I think in the ASP.NET area, people are actually fairly used to that.
That might be true for like kind of relate the name.
Well,
Yeah, there's a lot of people where when I use the term inbox or out of box or out of band, they're like, "What?" I'm like, "You have to reference a NuGet package, or you don't," and they understand that.
There's a difference between the term we use to describe the thing, and whether people understand what the name that name that we use, like Microsoft Data System Data, is in that vicinity, right? Like nobody uses the term out of band, right? Like but it's basically the difference between do you have to reference something externally, or is it auto reference?
But even that though isn't an exact definition, though, right? Because like registry inbox, you still need it.
Yeah, no, I mean, I'm not saying it's an exact thing, right? All I'm saying is that is, like, when you have both a system.x and you have a Microsoft.x, the Microsoft.x was the one that wasn't shipping in box. Like, keep in mind, the original naming convention for system was literally what is in box. And there's some exceptions from the rule, like Microsoft.win32.registry, but it's a very small set, and they did not make it consistent in V1. Like, the vast majority of things are, like, this was the guideline. If you want to be in system, you have to ship with the readers.
I mean, me personally, I don't ever see this going quote unquote inbox. Like, I don't think you should ever get this by default.
Also, I think inbox makes zero difference moving forward anyway. Like, I mean, the way core works, inbox or out of box is basically, if it's at the package boundary, it makes no difference. That's why I also said I don't have strong opinions one way or the other. I think there is some minor preference for Microsoft.data because it sounds more modern than system.data, but I think, practically speaking, I think either one will be fine. That's why I basically leave it to the team to decide whether they want to ship in Microsoft.data or system.data.
I had to step out for a second. What was I missed the start of the package discussion.
Basically what I said is like what you said in the very beginning. It's like, should the package be named Microsoft.data.analysis? I mean, I think we kind of want to name the package and the assembly the same. I think nobody has any disagreement with that. The question was should it just be Microsoft.data.analysis, or should we have something like Microsoft.data.analysis.DataFrame? And I think the conclusion was we don't do that because we think like whatever we will think is core will go into the or like core-ish, right, for this analysis area would go into Microsoft.data.analysis. And then everything that is on top, like, for example, the arrow support would just go into something else, right? So Microsoft.data.analysis.arrow, for example.
That makes sense. Like, yeah, I would hope that there's going to be other things package. So that was kind of why I objected to putting .dataframe in.
Yep, that makes sense.
These other things couldn't go in. So I'm happy with that.
Good. All right. Then we have 10 minutes more to...
Okay, so then we can just scroll to the bottom of all the operators. It's the same thing, just different stuff. Okay, so add is the same. This is the actual call. The operator calls the add method. The only thing is the first case, it takes a read-only list of values. Again, I doubt many people would use this, but if you had a data frame only of integers, then you could pass in values, which would be different integers for different columns. So the first column would get added with values of 0. Zeroth column would be values of 0. First would be values of 1. Second
so
column.
These are per column, not per row.
But the columns have different types, right? So
that's why I said
one.
Right. That's why I said I doubt many people. If you have a data frame that is only of type D, then you could pass in a values only of type D. Otherwise, it would throw.
Kind of another reason why you should probably do columns of up.
Yeah, or name the parameter column values or something, because looking at this, my first reaction would be rows instead of columns.
It's a single row, right?
So you would think that values of 0 would be added to everything in row 1. Values of row 0, then 1 row. Yeah, I guess I
actually thought this was meant the whole column. That would be anyway.
Yeah. But sure.
Yeah, I think add is not a great name if you call them data frame, because it's very unclear like what you're adding there.
Yeah, like if you stick with the columns convention, so like do dataframe dot columns, I don't know, 1 or something, and then add kind of makes sense. But like this way, I kind of unsure.
Because if you look at the indexers that are on this type, the indexers work in like enumerable of row numbers.
Okay.
And
right.
Now we're going back to columns.
Actually, yeah, I'm not opposed to removing the first API at all. We could just remove the add read-only list.
Yeah. Well,
values.
I mean, wasn't suggesting removing it, just renaming.
I mean, or you just move it to the thing we talked about earlier with the rows thing. Like if you say rows.add, it's very clear what it does.
Okay.
And
It
you add
feels
a
like it
single
adds
row.
a new row to it, though, doesn't it?
That's what I'm understanding.
Rows
but
not add feels like it should add those values as a new.
That's append, basically.
Right.
Whereas this is mutating the rows and then potentially returning a new object or mutating them in place.
Maybe I misunderstand.
Still feels super confusing though. Like
Yeah.
like list of t dot not append dot add, right?
Yeah. So append is here's a brand new row, please tack it onto the end. And add is take the existing elements and
Do
mutate
addition.
them.
Yeah. This is doing some.
Element wise add.
Yeah.
Oh no, I get what you're saying. This is literally the same as the plus operator.
Yeah.
Basically.
Yeah.
But where you could potentially specify a different value per column instead of a constant across the entire grid.
Right.
I see now. Yeah, it seems those are. Yeah. To think about what we want to do with those.
The problem
Maybe
would be
we-
just I read only less taken object.
Actually, it makes sense, now that I think about it, that this should be per column rather than per row, because if you had things you wanted to add per row, you would add two data columns together,
Yes.
because you probably already had your data in a data column.
Yes.
Okay.
And there exists API on the column to add a column to itself.
Yes.
So okay, so this literally
Makes
will
sense.
add
The values
a value to every single cell.
in a column. You mean the first API? The first API which takes values.
Well, the values is the row, right? So you do it like this way, right?
Everything.
Yes.
Yes.
Yes, that's correct.
Yeah.
Exactly.
But you basically change the value of every single cell, so every row and every column, right?
Yes.
Yeah.
You said that's not expected to be a common operation, though.
Right, because I doubt many people would have a data frame only of integers or only of floats.
So why not just expose a way to add columns and then people can write their own enumerator to
It
say,
exists.
But this is exactly the same as vector multiplication, the matrix by vector multiplication, right? So it probably makes more sense to call it multiply.
This was the demo that we looked at the very beginning, right, where there was a delegate that you could pass in.
Right,
Like a
but my
like
question
a
is basically like, if we don't think this is common, then why expose it in V1 and not wait for feedback, which is what we normally say.
Okay.
I agree.
You would only leave the one that takes a single T, or would you also remove that?
I would keep that one.
Isn't that the same thing, though?
No, because you could mutate
That
it in
one's the
place.
plus operator. That one in the plus operator.
Well, no, but this
plus
has
operator
the,
just calls it the second add.
but this has the additional property that you can say in place true, correct?
Yes.
So you don't end up allocating a new data table.
Right.
or
I
data
kind of
frame.
feel like there should be like instead there should be only just columns and plus equals 1. That kind of would make more sense rather than.
So my question was, isn't this going to be equally as rare? Because isn't this the overload that just takes a T the same condition of you have to have an entire data frame of type T for it to work?
Um,
An overload plus equals. An overload plus
Yes.
equals.
Right.
But normally, yes.
it's rare.
One place
yes.
where you could use this, one scenario that I think of off of my head where I'd use this is if I do have a bunch of floating point numbers, right? And they're all floating points, all columns are floating points, and I wanted to scale the whole thing, right? Say they're all too big and I wanted to scale it by 10, something like that. I would use like the multiply .1, right? But potentially, like if I know that I want to scale this column by 0.1 and then this column by 0.2, you would do it in one operation.
Right, but
Where
why not? So we have
break
data
that up.
columns and we've got the column collection. So why not just expose these operators on the column itself? That way,
I think I'm in favor of just removing this add read-only list of values for now.
right. But so my question is for the one that only takes a T, you have the same problem where all columns and all entries and all columns have to be of type T. And that's probably rare. So why not just expose this on the column type, because you know that everything in the column is of that type T. And then users who happen to be in a scenario where they have everything is of T, they can just write the trivial code to, for every column, do this single operation.
Right.
So also remove the operator as well.
Right, because if it's super rare that you're going to have everything always of type T,
So I can
then
kind of
put it
see a
on the
scenario
column where
there's-
you know everything's of type T.
But there's one mismatch though. The operator, if it sees different, the operator does conversions.
Yeah.
But that one, because it takes a T, it does not do conversion.
So you could add 100 to everything, even if your columns are float, double, decimal, and
Right.
byte.
If you
You
use
can
the
have
operator,
heterogeneous columns.
but if you use the add, then you'd have to be types would have to exactly match.
Well, it would have
Right,
to be an
but
exact
all
match.
of the primitive types are convertible to each other. I mean, you can convert 100 to float, and C# does that for you implicitly. So I don't see the problem.
So if
For all of them, can you go from a decimal to a?
Well, no, but you can explicitly convert, and then you know that you're getting a possible precision loss.
So if I had columns of int, float, double, decimal, whatever, and I called add 1, that wouldn't succeed.
But like kind of
At the moment-
having this conversation aside, like I can see why would I ever want to multiply everything by some number, but I kind of don't see why would I ever want to add something to some value, like a constant value to like every kind of I don't see kind of scenario where that would be useful ever.
I have days of the week 0 through 6. I want to convert them to 1 through 7.
But you wouldn't do that with the overload, which adds everything to everything, right? You would just use work.
Sure,
on a
I would do it.
specific
I would do it on the
Yeah.
column that is day of week.
Well, and I think I also see a reason why you might want to scale everything by something.
Yeah, scale yes, but the add I cannot run.
Or even add or anything else. But I don't think that they're
That's-
common enough that users are going to necessarily need these in V1 versus just iterating the columns themselves.
Okay.
And if we do get enough feedback saying, hey, this is a common thing, then maybe we can go and look at like, could we expose something on, for example, the column collection to make that easier, or on the data frame itself to make that easier and more straightforward that it is doing this operation on all columns, etc.
So remove the operators and these methods on data frame.
Not the operators. I think he means only the add.
No,
method.
I was saying all of them because I think it
No,
only
there's
makes
something.
sense in the
Oh.
context of a column.
But
like the kind of the data frame multiplication where you kind of have pieces of data where you kind like kind of like matrix multiplication kind of operation. I can see that, but kind of this I
Well,
like.
even with matrix multiplication, unless you know the underlying T, you don't know what semantics you're getting.
Yeah, but like if you multiply one data frame by another one, then you kind of know what you're multiplying.
Yeah, but
it would have to be like kind
These
of
are
like
always
one,
element-wise.
one row
Right.
of the data frame.
Right, but even if it's element wise, you're saying like if one of your columns is of type string, this is always going to fail. If one of your columns is of type int and you're multiplying it by 0.1, now you're converting it to float,
right.
and you're getting hidden semantics because one of your columns happened to be int and the other ones were float, and now you've messed things up.
But the compiler does the same thing though. You multiply an int with a float, you get a float back. Right. It follows the same semantic.
Right, but that's also not done on user-defined types, and we've said you shouldn't do that for user-defined types. Because it's not, for example, our vector types, they only take the T for all of their operations because you don't want to take a vector of int and convert it to a vector of float
Okay.
because there's not straightforward semantics between the two.
So you're constraining that types have to exactly match.
Right, because otherwise you get into all kinds of weird bugs and edge cases around, well, this matches but this doesn't, and now I've got different semantics and behavior, or
Okay.
it's not clear that int times float for a data frame should become float or should it become int.
Or if you
So
multiply
in that
it by int,
case-
should you get long or int or?
So
Yeah.
in that case, then this API is perfect for that, right? Because this constrains the T.
Right, but we also said that the T, that everything being of that T is rare.
Right. It's rare, but it's not never.
Right, but it's probably rare enough that users can write a for loop and just say for each column, do this operation.
And I don't even see like how would that be even faster to like do this instead of for each.
Right, because the for each is like 3 line. It's like 2 extra lines for the rare case, and we can then add an API if enough people ask for it.
Technically, even in that case, from the data frame, you go to the base column. And then from the base column, you go to the actual concrete type and then call the API on the concrete. Sure, it's like 3-4 lines. And
if someone did find it common enough, they could write their own helper method. If they found it common enough for their own code base.
Problems you were talking about, Tanner, are we going to have the same for the methods on base column, the data frame column, the base type? Like if you scroll to that,
I don't think there's a good way to handle that one. So for that one in particular, you could constrain that the thing you're multiplying by matches by doing a type check, but that's the problem you have with non-generic types in general. But that's no different from, like, for example, if you have iList, because it's non-generic, it throws if you try and add a whatever the actual base type is for the generic constrained version.
That would make it significantly less useful, though, right? You said had a base column of ints. It should be easy enough to like add 1.5 to it and expect that you get a float column out.
Well, I mean, but there should be a way to say, like, I want to convert this type to a float type and make that explicit, because there's a change in semantics and a possible loss of precision there.
Right, but then you added a float, so you know that it's going to happen.
Well, not necessarily. You don't necessarily... There's lots of people that don't understand floats. And for example, multiplying by 0.1 is not the same as dividing by 10. They compute different results.
Yeah.
And people think of it like normal math, and it doesn't work like normal math, and they get bugs because of it.
So the Common Core .NET.
You still have the bug because finite precision math enforces rounding error and therefore differing semantics.
But we're also saying that the return type of the data frame would be different at that point. Like if you multiplied by a float, if the input was an int, like you would get back a data frame or a data column of float.
Right. Oh yeah, I was just going to say that.
Right. And I was just saying that should be explicit. That way users know they're doing a mass conversion of data, and they should because you're not just converting one piece of data, you're converting all the data in that column to float. And
right, but none of them are in place though.
For example, you can't convert an int array to a float array.
You could
Correct,
possibly
but I can make a copy of that int array as a float array.
Yeah, which should be an
doing.
explicit step, is what I was saying.
Possibly, like maybe like both the key and the output T should be defined on the generic.
Yeah.
This way, you kind of know what you're getting.
Yeah, that I think would be acceptable if you had T and U, where you said here's the input type and here's the required output type. But that would also make the code very complicated.
Yeah, like the call site being easy. There is value to the call site being easy, right? And if I don't really care what the output type U is, if all of the APIs just continue to work anyway, why do I have to specify it?
The reason they're specified anyways is so that you know that you're getting the semantics of I'm converting the underlying column type.
It's
Yeah.
kind of confusing because like if you have columns of ints and you put like something like higher than half of int value and then you multiply it by another int, should you get the int back, which overflows, or should you get the long?
Well, if you're in
I mean,
C#,
Which is not how
yeah.
C# works.
But the thing is, if you're writing C#, like you have one expectation of how it works if you're just doing regular scalar math.
So like
Yeah.
If you're in this world, that
basically
that
like
assumption might
math
not hold.
people and the C# people will have different expectation
Yeah.
of what the output is going to be, and that's why maybe you should
And
use
then
it.
other languages like F# that don't really have implicit conversion will have another expectation entirely. For example, in F# you can't multiply an int by a float. You have to explicitly cast to do that operation.
Okay, so there, I'm seeing at least two different things here then. So in C#, if I say int plus long, I get a long back, right?
correct.
Yes, but if you
But there's no conversion. Like Like if I said var something equals int plus long, I know that the var is actually a long.
Correct.
I'm not explicitly casting it. And this is
There's
doing the same
there's
thing.
an implicit conversion, but yes.
Yeah, so this is doing the same thing.
Right.
So I'm not actually converting anything. I'm only copying it into like a different data type.
Yes, but then there's also the case of you're taking int or long and going to float, which, while it's implicit, unlike other implicit conversions, it's lossy.
Sure.
Which means that it's not a safe conversion to do by default. And I would say if C# were to do it again, it should not have copied the C behavior for that because it causes a loss of data.
And it's, I think, the only case where C# will do a lossy implicit conversion.
But then the alternative to that is to never have any sort of conversion.
Which is probably the safer option and the more sane option when you're working with user-defined types like this, is to just say the user has to explicitly insert the cast here so they know that they're transforming the data type from T to U.
I mean, I understand what you're saying. I just don't think the trade-off is worth not having the functionality itself.
Well, I don't think it's necessarily common enough, and you already said yourself it's not going to be very common that the user can't just insert that cast the one for loop where they're doing it.
No, that's not completely. I said it's not common enough that you have a data frame of ints and you want to add a ints to that data frame. But it would be common enough to have a data frame of like primitive types and then add like 5.5 to it.
And then everything gets converted to float.
Yes.
And why can't they just explicitly say for loop as float or convert to float?
There's a difference though. So when I say like data frame plus 5.5, I get a completely copy of the data frame. The initial data frame is still there. The way you want it, you would have to go to this data frame, take the column, somehow convert that column of ints, let's say, to a column of floats, and then add 5.5 to it.
Right, which would be,
Exactly
there
what
should be
you
conversion methods to say, I want to convert this column from type int to type single. And then you can freely add 5.5f.
I have a scenario question real fast. I'm interrupting, sorry. If I'm coming from other languages, other frameworks doing this, do they have a concept of different numeric data types, int, long, float, single, decimal, double? Or do they just say it's a number or it's a string or something else?
Like MATLAB, that's
Yes.
numbers, I believe.
Right.
Well, I don't know about MATLAB, but Python has primitive types. So it does like int, long. I don't know what they call float, but they're a float, whatever their type is.
But I'm expected to be aware of the fact that my column might have values of those specific primitive types.
You're not expected to be aware unless they throw an exception. So, for example, in pandas you can do int plus string, which will convert the whole thing to a string. It doesn't throw an exception.
Sure.
What does int plus string return?
It makes the int into a string and then does a concat.
And then
Same thing C# and VB and everyone else.
Don't go there.
Right. So we're
It
not.
returns not a number.
It's not a number.
So we're not that bad. So we throw conversion for whatever the C# compiler throws an exception for. This thing throws an exception.
which I don't think makes sense from the perspective of this is a .NET framework library and there's other languages other than C# that will reasonably use it.
Right, and that kind of led to the question that I just asked you a few minutes ago, which is if you're coming from other frameworks, other libraries, and you're not used to thinking about the type of number
Right.
or the actual type that underlies this,
Yeah.
are we actually doing a disservice to our customers saying you can't think of it as a number, you have to think of it as an int, float, double, long, byte, s byte? And I don't know the answer to that because I don't know the types of customers that can be. But if those customers wouldn't necessarily have that understanding, then it would be a good argument for don't make them worry about TU, everything else, just have everything working.
Well, the problem with that, though, is people who expect it to work like math then don't understand why it doesn't work like math when they try and do other operations. And so there's if you're using a programming language, you have to have some understanding that things don't work like math.
Yes.
And therefore you have to understand
Depends on the
types.
language.
And it's a trade-off. It's absolutely a trade-off.
And
Like
if
it-
someone really wanted to write a wrapper library that
Yeah.
that added these implicit conversions, they could.
Well, it comes back to what Emo said earlier too, which is like how much do you want to make an API that just like I want to get my job done, just do something that resembles correct behavior, versus I want very tight control over what specific operations are being performed.
I think that's also the difference between a high-level and low-level API. A lower-level API, like is exposed in a framework, should generally be explicit, and then you should have higher-level things like an Excel spreadsheet, which uses it internally and does implicit conversions to make it easy to use.
So maybe we should be looking at the more base-level API, which requires strict type conversion, and then separately consider friendlier things on top of that.
My opinion is like we should stick with stuff we 100% are 100% sure we need, and like whatever we are kind of unsure is a little bit ambiguous, I would pull it out, and then we can always add it later if we have a feedback. Like if we go with everything, then we cannot remove it anymore once we. So
yeah, which is kind of along the lines of let's wait for more feedback before exposing APIs that we think might be rarely used or that we could trivially support today with like 3 to 5 lines of code versus one API call.
Because under the covers, you have to do a type check anyway, correct?
Eventually, yes. But like when I do the add of t value, like in this case it would throw, but in the operator case I could convert the float to an int if it's an int column.
Right. And you were saying that this t has to match the actual t of the underlying type?
Yeah.
So then this API would be the what you had proposed.
Yeah.
Which is it must be an exact match.
Right. That's what that one is.
Yeah.
It's only the operators which are which you don't like.
Which is also confusing because operators and the friendly overloads are supposed to have the same behavior. That's why they're the friendly overloads for languages that can't support operator overloading.
Interesting.
Why are you?
The
why
framework.
am I not understanding this? So you're saying the operator overloading.
So framework design guidelines say that if you expose an operator, you should also expose a friendly version of that operator. For example, if you expose op addition, you should also expose a method named add. Those two methods should have the same behavior because the friendly overload is for languages that don't support operator overloading. And so if these two don't have the same behavior, you're also adding another logical step of this doesn't make sense to other languages that would expect them to have the same behavior.
Okay, I see the mismatch there. I agree. We'll have the discussion about whether you like the operators or not.
Yeah, and I don't like the operators because of implicit conversion and loss of data and confusing semantics. I think that should be very explicit to the user because they should be aware that they're changing the behavior, the semantics, and the typing of everything. And for the same reason that you can't take a regular, like C# allows you to convert scalar operations. It doesn't allow you to convert arrays of data between two types. There's no implicit conversions for those.
But this is element-wise though, so
yes, but it's still the same principle. You can't take an int array and convert it to a long array. You have to go through an explicit extra allocation and then a conversion step to make that work.
Just out of curiosity, what if we had operator plus primitive data column int left, primitive data column long right, and that the return type of that was primitive data column long? Would that be sufficient in your mind?
I think that would make it less confusing, but I think that'd still be rare enough that the user could just insert a cast or their own helper method to do that.
Or because I mean, you would get a crazy combinatoric explosion there,
right?
But it would match the semantics in that
or
it's left,
C#.
long, right.
It would match the semantics for C#, not for F# or other languages that don't have implicit conversions.
Well, it would also match what we do under the covers because we have to choose an implementation if we do want to support friendly, right?
Right.
Like we can't query was our caller C# or F#.
Yeah, and so I'm basically just saying like wait until there's feedback saying we actually need these, people want them, and them writing the for loop in the explicit cast isn't enough.
Okay. I'm thinking I don't like the idea. Because I mean, I don't know. Like from my perspective, if you're in a notebook, right, I don't think anybody's going to write a for loop. Like my concern is people are going to be like, oh, I've write a for loop to add like a float to an int column.
Sure, but why does the notebook have to be a one-to-one mapping over this? Why can't the notebook have an expression evaluator that does provide friendlier notebook-like syntax?
Right.
There's no reason why the notebook can't be a higher-level API that provides a friendlier interactive environment than the low-level API where people are writing direct code. And
Maybe I should have said the people who use I assume, well, this is my perspective. The people who use this, I don't think they would want that low level of a control over the types that they're adding and the return type and things like that. That was my perspective. That's why the API looks like that. That's why it doesn't have the stuff that you said. So we should wait for someone to say, well, yeah, if we ship something that's so strongly typed, like you say, and somebody wants like a loosely typed API like this is.
Because you can always build a loosely typed API over a strong typed API.
Right.
It's very hard to build a strongly typed API over a loosely typed one.
Okay.
And I'm tired of people filing bugs of, I have an integer that's over 2 to the power of 23 and I've converted it to float. Why isn't it equal to the same value? We just had a time span bug because of that with long.
What I'm afraid of though is like I just want to do something trivial like add 1.
Yeah, and people would be really frustrated if you had to like do that. That's what I was saying. That I don't know if they want that level of like you're saying you add this loosely typed API on top of that, right?
Yeah. Or for the strongly typed one, you just write a for loop and you have a convert to int32. If it's already int32, it's 0 cost. And if it is an actual conversion, you do the conversion, you do the addition.
Honestly, like I would only add the operators to the strongly typed columns. That would be only place I would.
Right.
And that is kind of makes it clear what's gonna happen.
But
and like any other case where you're kind of not sure what the type is, I would not add any operators because I don't actually know what's gonna happen.
well, I would reject that because I want to say that if you have you can do 1 minus like int column plus like a float column. Like that should be an expression. That should be like that should work.
Well, you can define the operator for the primitive type column int and primitive type column float, right?
Right. And I'm saying like if like the int column is not actually like an int, it's like a base column. Like if you have a data frame that has an int column and a float column, the concrete types are primitive data frame column of int and primitive data frame column of float. But when you do 1 minus like df of int plus df of float, that I think should work.
Right, and it could work. You would just have to explicitly say as float or as int. That way you know what type that you want as the result.
Oh man, the expression's so bad.
The other thing is if I change my data, like if I go back to the CSV file and just put 0.0 at the end of all of my column, or at the end of all of my entries in a given column, like my code might blow up now. Because everything is now a primitive data column of double instead of a primitive data column of int.
Right, but you should also, that's only going to be a problem with type inference, which we've already said is probably a bad idea in production code anyways, because...
Well, not necessarily, because if I have to get the column, cast it to a primitive data column of int, and then call add 1, now I need to go find that call site and change it to a primitive data column of float, and then call add 1.0, right? Like it's something that I won't actually notice until runtime that my code blows up.
Right, but that's always the case when you're pulling data from an external source.
Yeah, it just seems...
If you have a database
for like a prototyping and kind of like if you just writing like a one-off, I wouldn't mind like inference, but for any production code, that's just doesn't.
If you have a database, like a SQL database, and you're pulling data from it, you have to know the type, and if they change it, you have to update your code.
I get that. It's just, it doesn't sit well with me in the sense that I've made seemingly a minor modification to the CSV, and now it has ripple effects throughout my code. I mean, I kind of get why it is. It's just, it makes the API harder to use.
It does make it harder to use, but it also helps prevent bugs, because then you're going to have to be very clear that, hey, my value, which used to be, 2 to the power of 24, is now something different.
But also, you want to add +1, right? You can say column like, I don't know, like something, and then say map or whatever, like the function you just set and just add +1, right? Pretty much simple expression.
Not as simple. Column plus
It
one.
is not, but it's actually at least super explicit what you're doing.
I mean, basically, I would have
That's
to call.
simple
I'd have to figure out what the T is, and then call convert.changeType.
No, you could just say, you could have a convert method which says, whatever the data type is, convert to this new data type. And if it's already that data type, it's no op. It's no different than, for example, all of our vector APIs, where we can say you have a vector of t, and I want to treat it as a new vector of t, even though it's already t.
So
Or
primitive data column of T would get a new API, which is give me
convert
an
convert
object
to
or
Primitive
something.
column
no,
of
no
new.
it would be convert to new
Okay.
primitive data column of type t. And so it would convert from the existing t to the new u type, and if it's already that type, it's a no op,
Yeah.
which is how vector of t, for example, works. And makes it makes it very clear and straightforward what's happening. And it means that you can always make sure that it will work, regardless of what type it was interpreted as.
Yeah, I can see that.
So if somebody makes a new column, they'd have to make all the to methods, or they would column type. I mean,
Those virtual methods, if they're introduced as virtual, would probably throw not implemented exception by default.
right, but this
Primitive-
would not be virtual.
Convert. If you define your own column, you would want to have those conversion methods. You would want to implement them if you subtask.
Right.
Right. No, but your method, the API itself was. Oh, you had a U in it. Okay, never mind. Yeah.
Yeah, and you're going to hit problems with people with custom types that don't want implicit conversions or can't have implicit conversions. And it seems like a good idea for primitives, maybe, but once you look at like the big picture, custom data types and everything else, I just don't think it flushes out.
If we have a strong feedback, we can always add the easy.
Right. Yeah, there's nothing preventing us from adding the APIs if we get feedback, including if there's feedback in like preview.
Okay.
Like on the other hand, if you already add it and you
It's
have strong opinion, this is like stupid, we don't know what this means or like how to think about it or something, you kind of just remove it. I'd rather go incrementally add it. Trying if you know work.
We should probably call it a day.
Yes, we should.
We still streaming?
We are.
Wow.
Because I didn't press the stop button yet. All right, so I think we are done.
Did
I will
anyone
share
online
notes.
say something, or
Huh?
are there like any comments on like
There were some comments early on the span conversion, but that's pretty much it.
that people get bored of?
All right.
Oh, yeah.
Thanks, Eric.
MemoryMarshal.cast is not reinterpret. MemoryMarshal.cast is, let's try a reinterpret cast and see if we can make something sane happen. Reinterpret cast is unsafe.as.
All right, bye-bye online.